Alright, so today I'll be explaining one of the winning submissions from the 28th IOCCC, which is the International Obfuscated C Code Contest. As you can see, this is a piece of C code which looks strikingly like a moon, and this is on purpose. But it looks completely unreadable because hidden in this mess, it's a program which can calculate and display the current phase of our moon in our terminal. As you can see, I've run the program, and this is how the code output is. So I'll be explaining this piece of code. Now, for obvious reasons, I'll be explaining using the cleaned up version because this is too unreadable. But it's the same thing. Now, at first, we are initializing a, b, x, y, and z. So a will be used later. B is the number of cells that is used for drawing the moon. As you can see, if you count it, it will roughly be around 44 cells. X and y will be used for our coordinates, and z is used for shading. Now, at first, we are setting a to this magic number. Now, this is the lunar cycle period, which is about 29.53 days. But if we convert it to seconds, this will be the exact number. Now, we are setting x to minus b. So, because we are drawing it from the left side, so we have to use the negative coordinates. So, x will be around minus 44, and y will be 2 minus 44, which is minus 42. This is because in an ASCII art, we can find that it is more tall than it is wide, so that's why. Now z we are using the time function which is included from time.h. This will give the time this time 0 will give the current time, and when minusing it from another magic number, this magic number will this will give the Unix epoch time for the first new moon since the Unix epoch time started, which is about January 1st, 1970. And we are calculating it, we are dividing it by a for getting the exact cycle, and we are using some bit shift by 9 so to avoid a floating point, and we are dividing it by a for some other reasons. Now next we are drawing the thing. So for drawing, we are advancing the x, so from minus 44 it will go to minus 43. Then after that, if it is if it is more than 44, we are resetting it back to minus b, so which is minus 44. So this will occur when we are going to move to the next line. So y is also going to be plus 4. This is obvious. This is because, as I said, the ASCII art is more tall than it is wide, and we are using this 10. So 10 is the new line character. We are using it for obfuscation, but if you replace it by new line, there will be no problems. After that, we are doing another one. So if x is less than 0, we are checking this piece of code, and what this basically does is that it checks for whether we are inside the circle or not. So if you are outside the circle, we are using 32, which is also an ASCII character for the space, as 10 is the ASCII character for the new line. And after that, we are setting a to 1 minus x. In the last piece of code, this is a bit more complex. We are calculating the edges and the shadows, so to mark the dots and the hashtags. So after that, in this, we are using the a star, and we are bit flagging z and doing some things. This will calculate the current terminator position, and this piece of code will toggle the phase depending on whether we are depending on the moon cycle. So it will toggle it from hashtag to a dot. And after that, we are checking if y is greater than 44. If it is, we will continue it recursively. We are calling the main function again, so it will call it again. And if it is not, we will exit the code. So that is it.